This video is on graphing cosine functions, similar to the way we graphed sine functions in the previous lesson. So here we have a circle that we will say is radius 1, and we're going to go around to these key points on the axes and label their coordinates. So the angle here at the starting position is angle 0, and the coordinates of that point are 1, 0. Then we'll do that at each of these. Up here, the angle is pi over 2. Right there. And the point is 0, 1. Over 0 from the origin and up 1. And then the angle here is pi, and the coordinates of that point are -1, 0. The point here is 3 pi over 2, and the angle is 3 pi over 2, and the point is 0, -1. Okay, so having that information handy is helpful. This is the parent function for cosine theta, and now we're going to put in the x-coordinate of all these points around the circle. Now remember that cosine theta is the x-coordinate over the radius, but since the radius is 1, 1 divided by 1 is just 1. I'm here at the angle of 0, x-coordinate is 1 divided by 1. Then if I go up to pi over 2, the x-coordinate is 0 divided by 1, which is just 0. And then over here at pi, the x-coordinate is -1 divided by 1 is -1. Down here, x is 0, and back to the beginning, 0, or remember you can think of this as 2 pi, and we're back at 1 again. So the cosine function starts at 0, 1, and then pi over 2, 0, and pi, -1, and 3 pi over 2, 0, and 2 pi, 1. And if you wanted to put in a few points for accuracy here, if you were at this point, that is at pi over 4, the ordered pair right there is 0.7 and 0.7. That's the 45, 45, 90 triangle here with root 2 over 2, root 2 over 2, 1. So you can put in a couple more points for accuracy. And then try your best to draw a smooth curve. Now one thing that is very important with the cosine curve is that you realize that this point here at 1 is a maximum. So as you approach 1 from the left side of it, make sure you're coming up to it and then going back down after it. It's kind of hard to do this on the computer. Hopefully I'll get a nice smooth curve. Then here, as soon as you get to 2 pi, right after this, you're headed back down. So make sure that your curve does that. A common error on drawing cosine graphs that make teachers crazy is students doing something like this. Maybe coming like this near this point, or just kind of going right through it and continuing to go up. So try not to make those kind of errors. Curve it around over the top. My curve's pretty good. It's a little sloppy right here. Hopefully you can sketch one better. Okay, then this part is just for you to extend the cosine graph. So I'm going to fill that in, and you try it and see how you do. Alright, so there's a reasonable looking cosine curve. I plotted the points first and then tried to draw a nice smooth curve through it. Hopefully you can do that too. Okay, so here's our first graph with some transformations to it. I think it's a good idea to put the parent table right next to any function that you're doing. It's easy to make mistakes with that. So this will just be y equals cosine theta. and we want to put in the parent table values here. So picture this circle and think x is 1, 0, -1, 0, 1. It's slightly different than it is for the sine function. So 1, 0, -1, 0, 1. And then the rules to get the way to get the coordinate rule for the top of the table here is to look at what's going on here. This one says half of theta, so you have to do 2 theta to undo what is being done to the thetas. And then you don't have to undo for after the cosine, so you can just say 3 plus 4 times the y value. Okay, so now we're going to take these theta values and multiply them all by 2. So 2 times 0 is 2. Pi over 2 times 2 is just pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 is 4 pi. And then my y values, 1 will be 7, 3 plus 4 times 1, using this y value here. And then 3 plus 4 times 0 is just 3. 3 plus 4 times -1 is 3 minus 4, or -1. And then it'll be back to 3 and back to 7. So I'm starting over 0 and up 7, and over pi and up 3, and over 2 pi and down 1, and over 3 pi and up 3, and over 4 pi and up 7. So that's enough for one cycle, but it does ask you to graph 2 cycles. So I'm going to do this again, and you can see this little pattern of over 2 and up and down 4 units here. So I can just go from here. I know next I'm going to go down from here. So I went over 2 squares and down 4, and then I need to go down again, over 2 squares and down 4. And now I've reached the minimum, and I'm going to go up, and over 2 and up 4 again. So now we need to try and draw a nice smooth cosine through here, and remember that this is a maximum. So as you approach that point, you need to be approaching it from below it, and then come down. And this is a minimum. And these should just be nice smooth curves here. Again, you can probably do a little better on your paper than I'm doing here. And this last one is a maximum, so curve around and then go down after that. And add these little arrows. Okay, so domain is all real numbers, or -infinity to +infinity. The range, the smallest y value is -1, and the highest y value is 7. The amplitude is the distance from this midline. That color's not showing up very well. The distance from this midline. This isn't an asymptote, it's just the middle of the function, such that half the function is above it and half the function is below it. And then you can get your amplitude right here, from the midline to the top, which is 4 units, or from the midline to the bottom, which is also 4 units. You can also see the amplitude here, and you can see the amplitude right here. Now the period is the length of one cycle. So if you start here at 0 at a maximum and go to the next maximum, that length is the period, which is 4 pi. can also see the period here. It starts at 0 and ends at 4 pi. So the period is 4 pi minus 0. And you could also get the period from the function. Remember we went over last class that the period is equal to 2 pi over the b value, and so you could get the formula from there. Alright, one thing we forgot to add to this graph up here was any place with the amplitude and period. So you can see here that the period of the cosine function is 2 pi. Starts at 0 and ends at 2 pi, and the amplitude of the parent function for cosine is 1. Okay, so I think that will be enough for you to get the lesson. There'll be keys available in class for you to check your answers. I did want to show you one more thing here. Let me get the video set up. Okay, so here's number 5 from the notes today, and I thought it would be good if we just set up the top of the table. So this will just be for the cosine again, and we know that the parent table is 1, 0, negative 1, 0, 1. So the rule for this input values here, I need to undo what's being done here. So if I put a value in for theta, I would first add pi over 6 and then multiply by 3. So I want to undo what's being done to theta, not only the order of it, but also, not only the operation, but also the order. So here I'm going to put my theta in, and I need to undo multiplying by 3, which will be 1/3. And I need to undo adding pi over 6, which will be minus pi over 6. Notice here I would deal with the pi over 6 first and then the 3. So here I'm dealing with the 3 first and then the pi over 6, reversing the operation and the order of the operations. So then this will be negative 8 minus 12 times y. And I'll take all of these values and do this to them. So just to show one of these here, if I did the 3 pi over 2, it would be 1/3 times 3 pi divided by 2 minus pi over 6. And just take your time on these. Now these 3's could cancel, but I would be better off here to keep my denominator of 6, so that I can subtract pi over 6 from 3 pi over 6, which is 2 pi over 6. So this was this one here. I'm going to get 2 pi over 6, which I could also write as pi over 3. That would be fine. And here's pi over 3 right here, so that might have been better to write this as pi over 3. Sometimes it's handy to keep them over with the unsimplified, and sometimes it's nice not to. And then if I substituted in the 0 here, I would get negative 8. So this point is over pi over 3 and down 1, 2, 3, 4, 5, 6, 7, 8. Oops, this is counting by 2, so the 8 is right here. 2, 4, 6, 8. Alright, so good luck finishing this up, and after you finish, compare your answers to your neighbors or ask someone to check it over. Thanks.